Okay. So one component of risk management is testability. In some ways, a student several years back, over 5 now, I think, once said, this is on their post-mortem, time of the final exam, they said, like, now that I think about it, just about most of project management is really about risk management. I mean, it's really the whole thing is kind of risk management. And there's a certain sense in which that's true. But there are particular processes that we undertake, like testing and design for testability, that are really about effective management of risk. Make it easy to spot problems, make it easy to respond to problems if they're there. So let's talk about testability. Testability is a fancy sign for it. It's about ease of testing. Okay, we want our program to be easy to test. Programs often have a large amount of internal state. Sometimes you can only access that state indirectly. So imagine a big, awful function. It's got lots going on in there. There's a lot of things going on in the calculation within it, but it's hard to test that. You can't exactly stick probes in there and say what's going on each step of the way directly. We don't have tools that allow us to do that in an easy fashion. We have tools that might call that function and see if it gives a reasonable return value, but about what's going on along the way, it's kind of hard to figure out sometimes. But it matters. Often we're interested in knowing what is going on to figure out if it's right. Is it examining the right alternatives or what have you? And so it is for a lot of our systems. So, and if you think about the user experience, accessing it through a GUI, or graphical user interface, I'm trying to probe this very complex system, which is calculating things and so on through a GUI and see if it's correct. It's going to be kind of limited in terms of understanding. How correct is it? There's only so much I can operate with testing. And as a result, it can be difficult to test, but also difficult to determine cause for errors, for debuggers, for people doing debugging. Can't see what's going on. All you see is this error message. We don't know why we saw that error message. What's the underlying fault behind that failure? I'd like to distinguish, there's a very important distinction in this class, ladies and gentlemen, between failures and faults. General fault is the underlying cause of a failure. Failure is the visible manifestation of the problem. A fault is the cause of the problem. And debugging is about going from an observation of a failure to an observation to the underlying fault. Does that make sense? I'm trying to find what the problem is that's underlying it, right? It can be hard to find faults if you're operating through an overall GUI, right? So here, the goal of testability is to at least give some thought and some effort to put in place mechanisms to make it easier to do this, go from failures to faults, or to find failures sooner, to reveal issues more quickly. And there's several ways we do this, but two of them that I'll note a lot on are logging. Have the program report in its innards, even in that hoary algorithm, what's going on in the logging messages of different levels of priority. I don't want to see printfs. I don't want to see printlns just scattered there. I want to see logging framework calls that indicate this is a low priority error message. This is a low level error message. This one is a very high priority for very high level error messages that should be shown in much more frequent cases. So logging should be a different multi-level logging. Some things we just want to tune out, some things we want to tune into. When we're debugging, maybe we tune into everything. When we're just running the program, high-level tests, maybe we've only got errors and warnings on or what have you. And the second thing is hooks. Okay, both of these have caused confusion for students. I want to talk about them. So, let's talk about this. Testability. Testability. Ladies and gentlemen, it's a lot of practical things here. Testability is aided by the presence or support for a number of particulars. One of them is harnesses and drivers. Now, I don't know what they called this in 270 and 370, but basically, you're going to want to test your program through the GUI. You want to see the user experience. You want to get a sense of that. You want to do black box testing through the GUI a fair bit. Okay? None of that's in dispute. The issue is more, you want to do more than that. You want to test your system programmatically. What do I mean by programmatically? What do I mean? You want to test your system programmatically. What do I mean? Yeah.
Program?
Yeah, so you want to be able to call in an automated fashion different areas of the program, right? I mean, it's a program, but you want to be able to call it. You want scripts to be able to call it. You want to have code that will call your program and put it through its paces without going through the GUI. Why? Why?
It's sorry.
Oh, I was going to say, doing it manually is slow.
Okay, doing it manually is slow. Okay, but okay, fair enough. How if we had an automated way of doing it through the GUI? Let's say with Selenium, or let's say with Abbott, or some other testing tools. Why would a JRobot? So suppose we could drive a GUI automatically. Why isn't that the answer to all testing?
You probably aren't going to be able to get the same coverage that you could get.
You bet. Yeah, I mean, there's only so many things the user could do through the GUI, and those are good to check, but sometimes you really want to be testing, well, okay, I mean, make the most basic thing. You want to test at a unit level, right? You're not going to be able to easily do the unit testing through a GUI. You want to be able to do some integration testing. You want to do system testing, putting it through its paces, and going through the user, through the GUI, ladies and gentlemen, is two other letters. Slow. It's really slow. And now I have 5 pieces of chalk instead of 1. Okay, that's not necessarily a bad thing. Okay, so ladies and gentlemen, being able to drive your program through in an automated way through a script is really desirable. There's another thing though. What happens to GUIs over time? GUIs change, and they often change quite a bit faster than the API. So if you're doing it through the GUI, you're always doing it through the GUI, your tests are going to be breaking a lot. They got to be brought along. As the GUI changes, you got to bring them along. It used to be really bad. You would say, like, click on this Excel. You change the layout slightly. It doesn't work anymore. Now it's not so bad, but maybe you change the name of the button, and it's still a problem. With harnesses, you can also test repeatedly over many different inputs. You can record the output more easily. Redirect it to something. You can capture and maybe programmatically look for certain types of log messages, errors, or what have you, more than you could through the GUI. We'll come back to hooks probably next time here. Another thing that will be really handy is if you could allow multiple instances on a given client. So if you're testing your system on a desktop, if you're not limited to running the system one at a time, but you're instead having different processors running it or what have you, different windows running it at different points, that's really good. I mean, if it's accessing some resource, just locks a file, and then you can't run it on the same machine, that makes it hard to test as and as fluid a way, as convenient a way. Maybe you want to run it. You see an error here, and because remember, this is not only. It's really important to have these, but it's also important to support manual testing. Maybe you want to run it until you see an error, and then you want to, just stop it there. It's still running, and you want to go and fire it up again and see if you can go through the same steps and get to that same point. Try something different, see if the error still comes up. To do that, you need multiple instances supported on your machine. But if it locks a file and only one of them can run at a time, you've really limited the testing that can go on. Stubs, mocking, and fakes. You want to be able to support stubbing or mocking. You want to be able to have good support, so it could support JS mock or JMock or whatever framework, Makito, that you're seeking to use. Another thing, supporting a scripting interface. I don't expect that during this term, but it's a really handy thing. Support a scripting interface. Another thing, really big. It's an excellent best practice when you're running things out there on mobile apps or on users' desktops. Have error reports submitted programmatically to you. So if there's a failure that occurs, it catches it, it puts together a report, reports, where the error occurred in the program, the machine, operating system, a version of the code, something about the memory on the machine, perhaps, disk space free, etc., and it ships it back to you via HTTP. Posts it back to your server. Why is that good? Why? Why is that great?
Well, it gives you like a ton of information about what's going on and what went wrong.
Yeah, it lets you know that failures are occurring, where they're occurring, how often they're occurring, the nature of the machines on which they're running, or the devices, right? And that is really handy if you want to reproduce it. It may also include information about, what versions of libraries are loaded. Again, what version of this code, is it all occurring with old code? So you're just a lot more knowledgeable about what's going on. Allowing your system to be driven by config files instead of just by user frobbing of settings and so on. And this is very practical stuff. It's nice if your system, when you fire it up, you can tweak a config file and have it log more error messages, right? Have it do a lot more logging, more detailed logging. So it prints out not only error messages, but everything down to the level of info statements. So you can see complete information what's going on without it recompiling. That's really, really handy. We'll talk about hooks more next time. Okay. Maybe not next time. Maybe this time. Okay. There we go. Okay, ladies and gentlemen, test hook. The idea behind the test hook is it's a basic idea. I'm going to try to convey it in a few minutes here, recognizing that a lot of it has to be put into practice to appreciate it. So the idea is simple. The idea is when you do, as developers, you're developing your code, you do more than develop the ultimate code for the program. You also develop code whose job in life is to allow for testing of your program. The job of that code is to allow the program to be tested. It's often very small bits of additional code or very small bits of interfaces that are supported. And these interfaces might not be supported. You might have your class support two interfaces, right? Implements, interface A, implement, interface B. Interface A might be the normal interface that people use for your API. Interface B is a testing interface. Now, testing interface lets the client peer into the innards of that code. Peers into it to see what's going on. It can inquire for information that your normal program wouldn't. Maybe it's kind of auditing information. How many times this has been called? What some intermediate values were in the computation? What's in the cache right now? It helps you gain some information that can be useful for figuring out what's going on. And And test hooks are frequently created by developers for assertions. Folks familiar with assertions? Assert that this is true. They basically test our understanding as developers. And often you want to test something, and that something may not be something that is commonly supported by your normal API, but it's something you support on the test API. Okay. It'll test this invariant about the data structure, that it contains no nulls in the dictionary, or that it has no duplicate records in that dictionary, no duplicate keys, or that all of the items in the dictionary have counts of greater than 2, or what have you. It can check those things at runtimes as part of assertions. And these things can improve debugability because you can call these during debugging and third-party integration as well. Okay, we've just 2 minutes left here. There can be hooks for inspecting internal state, asking, what's your current state inside? You know, what's the current state of the system? What's the contents of the cache? What are the items in this data structure? Really useful. Really useful. Another thing you could do is to have hooks which will basically force it as if an error condition has occurred, as if the connection has been terminated, as if the database returned a failure, as if the disk was full. You could go in and force it into the state and see if it correctly handles it. You know, to actually test how it responds to a full disk, you don't want to have to fill your disk up. You want to be able to have a way to kind of make it seem as if there's been a full disk, right? So that's good. And diagnostic routines. We'll check the integrity, check the consistency of it, return size information on data structures, etc. Test hooks. Enabling, disabling logging is one of the best ones. Log if, connections, memory usage, keystrokes. Now, I got a question, and this is going to be my final comment here. I got a question from a student about logging. And I want to distinguish logging from complete tracing. The issue with logging is not to just have it print all the vagaries of what line numbers it's reaching and which exact functions are being called. The goal with logging is to be able to record frequently high-level actions which have occurred. By high-level actions, it may be connecting to a database, opening up a file, performing a sort, and finishing that sort. Performing the sending of a message. These are high-level actions of significance that indicate, oh, that process finished, or this process is starting up, and now that one. And they may print useful information, connected to a database, which database, and what's the particular table that we're connected to. So high-level logs as well as low-level logs, and the deal is you want different levels of logging. Some, logs perhaps to debug level, some to an error level, some to a level of info. So just sort of information. And you want to be able, without recompiling the program, to tune in to any of these different levels. To tune into everything, if you're debugging perhaps, to tune into only the errors if you're just interested in sort of going through and running the program for other purposes. So you want to be able to tune out or tune in, and logging frameworks that are out there will allow you to do this well. And Java 8 has a logging framework, as I remember. That's quite good. Lots of programming languages have good logging libraries these days. And those logging libraries can be turned on and off as far as reporting by different levels. Okay, that's all for today. That's all for this session. I will be seeing you in this very room in about an hour and a half, right? And folks are welcome to stay here. I don't think there's a class after this one, to the best of my knowledge. If there is, you'd have to clear out. Otherwise, you could just remain in the classroom as you see fit. Hi, yeah.